Well, we can learn a great deal more about the genetically determined initial state by appealing to a really uncontroversial fact, namely that the initial state is common to the species. So, for example, if my children had grown up in Tokyo, they would be talking whatever it is that kids talk in the streets in Tokyo. Therefore, and that's true quite generally as far as we know. So it follows then that evidence about Japanese bears directly on assumptions about the initial state for English, and so on, much more generally. Proceeding in this way, it's possible to establish quite strong empirical conditions that have to be satisfied by the theory of the initial state of the language faculty, a theory that's sometimes called universal grammar these days. That's adapting a traditional term to a rather different framework. These conclusions about universal grammar, about the initial state of the language faculty, they can be strengthened further in many ways, for example, by psycholinguistic experiments, which aim to establish what children know, typically with very little direct evidence, often none at all. Proceeding in such ways, one can learn quite a good deal about the initial state of the language faculty, and also formulate some rather serious and interesting problems for some eventual biology of language. One problem is, how do the genes determine the initial state? A second is, what are the brain mechanisms that are involved in the initial state and the later states that are attained? And thirdly, how do these states of the language faculty interact with other systems of the mind and the brain as language is used to express our thoughts, to interpret what we hear, or whatever else we do with it? Well, these are extremely hard problems, even at the peripheral levels of the motor systems, where you can almost sort of see the things that are there. Even there, it's extremely hard to answer questions like this. And that's also true for much simpler organisms and systems where direct experiment is possible, intrusive experiment. However, it may be that some of these questions are at least at the horizons of inquiry through the use of non-intrusive technologies of the kinds that are coming along. Studies of the electrical activity of the brain, for example, have led to some suggestive and rather surprising results in the last few years. There's no doubt that many of these questions could be answered, maybe pretty conclusively, if intrusive experimentation were possible. That's, of course, barred for obvious ethical reasons. Rightly or wrongly, these ethical considerations are held not to apply to other organisms, and a great deal has been learned about, say, cats and monkeys, for example, by implanting electrodes in the brain or raising them in controlled environments and so on. These investigations provide evidence about humans as well, insofar as the brain structures are similar. So a lot of what's known about, say, human visual systems or organization of motor behavior is based on the assumption that it's more or less similar to systems of other similar organisms, where it's can be investigated directly under the conditions that we allow ourselves, again, rightly or wrongly. However, essentially nothing is learned in this way about language, and the reason is because of the apparent biological isolation of the language faculty. You can't investigate the language faculty of a cat or a monkey the way people investigate its visual system and expect to find out something about the human language faculty, because the faculty just doesn't seem to be there.